Good morning, friends. I hope you are following the thermodynamic video lectures. The last class what we discussed means we derived the equation of PV relation in adiabatic process. Now today our goal is to derive the relation to get the relation between the T and V relations and T and P relations. We need to get the relations. So in adiabatic process, the system must be obey the separate law, that is equal to PV power gamma is equal to some constant. Let's assume this constant is equal to capital K. PV power gamma is equal to some constant. That constant we are assuming is equal to capital K. Now we need to get the relation between the T and V, as your present content is working on T and V. So here V term is available, but P term is there, extra P term is there. We need to eliminate the P term in terms of T. So to get the relation between the T and P relation, we are taking the ideal gas, that is equal to ideal gas equation PV is equal to nRT. Now let's assume this is the constant itself, then the P is equal to, can we write like this, nRT divided by V, where V is sending to the other right side, then here is the multiplication, it will go to the division. Just substitute the values in this above equation, that is equal to nRT into V power gamma divided by V. So here nothing is there, power 1 will come, this denominator to numerator, it is the V is going, so then V power minus 1 will come, that is equal to some constant I am taking. Then T into V power gamma into V power minus 1 is equal to some constant divided by this nR I am sending to other side, that is equal to nR I am getting. Then here T into V power gamma minus 1 is there, then some constant divided by nR, that another constant we are assuming, that constant is equal to capital K. This is the relation between the T and V in adiabatic process. So here it will, this equation will tells that the relation between the T and V in adiabatic process. I hope you understand. Now let me go to the another relation, that is equal to relation between the T and P in an adiabatic process. Sorry. So as we know, the once again I am taking the adiabatic formula, that is equal to relation in the PV relation in adiabatic process, PV power gamma is equal to some constant. Now our goal is to get the relation between the T and P. Sorry. So here we are having the P value already, is the P term is there, then we need to eliminate the V term in terms of T. So to eliminate the V in terms of P, in terms of T, we are taking the ideal gas equation, that is equal to PV is equal to nRT. Then V can be written as nRT divided by P. So that means where the P is there, we need to substitute, where the V is there, we need to substitute that value in where the V is present, that value can be substituted as a nRT divided by P. Then the above equation can be written as nRT divided by P whole power gamma is there, that is equal to some constant. Then we can write it as a P whole power gamma is there, that is equal to P power 1 divided by P power gamma, that is equal to into nR whole power gamma into T power gamma, that is equal to some constant is we are getting. N is the constant, R is the constant, gamma also is the constant, that is equal to Cp by Cv. This total constant I am sending to other side, this side I am sending. Then P power 1 gamma is there, gamma is sending to the numerator to denominator to numerator, that will become as a minus PV power minus gamma, then P power 1 PV power minus gamma into T power gamma, that is equal to some constant divided by nR whole power gamma. So this must be another constant, then PV power 1 minus gamma into T power gamma is equal to another constant, that constant also we are taking a K. That is also another constant. This previous constant and this constant is not a constant, not a equal, then we are taking a small k, another constant of that one. So this is the equation which give the relation between the P and T and adiabatic process. Now we have writing the all three equation at one place. So the PV relation in the adiabatic process is equal to PV power gamma is equal to some constant. So if we get to the TV relation in adiabatic process is equal to, what is the formula? TV power gamma minus 1 is equal to some constant. So now we are taking the TP relation in the adiabatic process is equal to, what is the formula? P power 1 minus gamma into T power gamma is equal to some constant. These are the three relations in adiabatic process in PV and TV and TP. I hope you understand the lecture. Thank you.